Day 542 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2125, number of laser beams in a bank. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Anti-theft security devices are activated inside a bank. You are given a zero-index binary string array bank representing the floor plan of the bank, which is an n by n 2D matrix. Bank of I represents the ith row consisting of zeros and ones. 0 means the cell is empty, while 1 means the cell has a security device. There is one laser beam between any two security devices if both conditions are met. The two devices are located on two different rows where R1 and R2, where R1 is less than R2, and each row I, where row 1 is less than I and I is less than row 2, there are no security devices in the ith row. Laser beams are independent, i.e. one beam does not interfere nor join with another. Return the number of the total number of lasers and laser beams in the bank. All right, y'all, so that may seem a little bit confusing. So let's go ahead and take a look at this example just to make sure that we're doing this problem correctly. So in example 1, our input bank equals an array of strings, first string being 011, 001, then the second string being 000000, third one being 010100, and then we have 001000. Boom, the output is 8. Explanation says between each of the following device pairs there is one beam. In total there are 8. So let me go ahead and copy and paste this input over here so y'all could get a better visual representation of what's going on, right? So let me just do this. But each one of these strings represents a different row. So this would be row 1, this would be row 2, this would be row 3, or excuse me, row 4, row 3 and row 4. So as you can see, each one of these rows represents each one of these rows over here, right? And with the 0 being empty and the 1s being a laser beam. So as you can see, we have a 0, then 1 1, that means, or excuse me, 0 1 1, that means we have no laser, then laser, laser. Boom, then 0 0 1, 0 0 1. As you can see, the lasers fall in the places where the 1s are and the 0s are blank. Boom. Now, as you can see, we have some requirements that we need to check to make sure that the lasers will reach each other, right? So the two devices are located on two different rows, and for each row of I, row 1 is less than I and I is less than row 2, there are no security devices. So as you can see, as we are going from this row to this row, there are no security cameras in this row. Boom, and these are on two different rows so they can connect. And you can see over here, these ones right here can connect to each other. This one right here can connect to this one and this one. This one over here can connect to this one and this one. And these two ones can connect to this one down here just like this. So let's look at the explanation. It says between each of the following device pairs, there's one beam. In total, there are 8 beams. So these just represent the different rows and I guess you could say columns of where the lasers are. And then it says, note that there is no beam between any device on the 0th row with any device on the 3rd row. So once again, there's no devices on this row at all because it needs to be like that to satisfy this condition. Then it says this is because the second row contains security devices, which breaks the second condition. So, boom. So let's take a look at example 2. Example 2, same similar, same principles apply. In example 2, this time we have our bank equals an array of strings. First string being 0 0 0 means there's no laser beam. Second row or second string being 1 1 1, which means there are laser beams in everywhere in that row. And then last row 0, 0, 0 once again. So once again, you can see each one of these strings represents a different row. The output is 0. Explanation says there does not exist two devices located on two different rows. So since all of the devices are on the same row here, there's no other device for them to connect to, and it doesn't satisfy this first condition that says the two devices are located on two different rows. So in this case, the first condition is not met, so our output is 0. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we need to do is we need to track the number of devices or ones in the most recent non-empty row. So we could just declare a variable for that. We could call it var. We could call it last count. And we could set that equal to 0 to start. Boom. Then we need to get the total number of laser beams. So we could declare a variable called result. Set that equal to 0. That's going to store our output. And now we need to iterate through each row of the bank. So we're going to say for row in bank. We're going to open up the brackets. And we need to count how many security devices are in the current row. So we're going to declare a variable called cur count, set that equal to 0. Then we're going to come underneath that. We're going to say for cell in row where cell equals, open up the quotation marks and put 1. Come outside of those quotation marks, open up the brackets, and we're going to increment cur count by saying plus equals 1. Boom. Now, if this row has at least one device, it cannot form beams with the previous non-empty row. So we're going to come underneath this for loop, and we're going to say if cur count does not equal dot 0, then we're going to open up the brackets, and the number of beams formed is going to equal devices in previous row times devices in current row. So we're going to say result plus equals last count times cur count. Boom. Then we need to update the last count to represent this row for the next iteration. So we're going to come underneath this and set last count, equal to cur count. Boom. And then last but not least, we need to return the final number of beams found by coming right here, and we can say return result, y'all. Boom, y'all. That's all she wrote. Let's go ahead and give it a run. Make sure it runs properly before we submit it, because we all know how LeetCode can be. Okay, so it's accepted. So let's go ahead and submit it. Make sure it's still accepted, y'all. Let's see. And look at that, y'all. 63 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.